First question in the exercise is classify the systems given by the following equations as linear or nonlinear, time variable or time invariant, continuous time or discrete time. So, the equations are A t squared plus 1 dy by dt plus 2 ty equals x, B yn equals cos n omega xn, C yn plus 1 plus y squared n equals 2xn plus 1 minus xn, D 2d squared by dt squared plus 2y dy dt plus 4y equals 2 dx dt plus x, whereas usual notation x is represents the input and y the output. So, this is the first question. Second question will give you a series of functions of time 1, 2, this is 10, this is f1t, x axis is always time, f2 1, 0, minus 4 and this is 0 from this is f2, f3 1, 2 like this is minus 3 and here is minus 4, everywhere else is 0, this is f3, f4 1, this is 2, comes down, this is 3, this is 3.5 and value here is 2, the value is minus 3. So, 4 functions of time are given to you, the x axis is always in seconds function of time and f1 to f4, you express f1 to f4 in terms of singularity functions. So, in terms of step functions, ramp functions, etc., you express this, find out expressions for this in terms of step functions and ramp functions, that is the singularity functions. That is the second problem. As a third example, let us take this circuit where a source Vs of unknown waveform is driving a circuit containing an inductor, a resistance and a capacitor, values are given. If the Vc has got this particular variation, the waveform of Vc is given, find Vs of t and express this in terms of singularity functions and sketch its waveform Vs of t in this given this circuit and this waveform of Vct. This is part A. Do a similar analysis for this circuit in which again the value of the voltage Vc is given by means of this particular variation, 4 volts to minus 4 volts, it decreases from 0 to 16 seconds and remains 0 for further values, other values of time. And if this is the value of Vc, find out the expression for Vs of t in terms of singularity functions once again and sketch the form of Vs in terms of using impulses, ramp functions and step functions. So, this is one problem which is an exercise on using the singularity functions. Okay. So, this is these are two circuits which you can analyze using the concept of singularity functions. The fourth problem, we have, let us take a circuit in which a switch is closed t equals 0, 1 ohm, 2 Henries, 1 ohm and 2 farads. Call this I1 loop current, call this loop current I2. So, this is a exercise in differential equations. So, write down the loop equations, write the loop differential equations in terms of I1 and I2 and in terms of differential operator D. B, taking I2 as the output and Bs as the input, write the differential equation relating the two. So, you have a second order differential equation relating I2 as the output quantity y and Bs as the input quantity x. See, if Vs of t equals 33 cos t, find I2 0 plus and I2 prime 0 plus the initial value of the second current and its derivative, assuming 0 initial conditions at t equals 0 minus in the inductor and capacitance, assuming that inductor and capacitance are initially uncharged. 1 minute. 0 initial current, no, we will put this assuming that, assuming 0 current in 0 current at t equals 0 minus in the inductor and the capacitor voltage Vc at 0 minus is 5 volts, and using this information, initial conditions, D, find I2t for t greater than 0. So, that means this is an exercise in the use of a differential equation approach. You have to find the initial conditions and finally find the total solution for I2 of t. Cut. Fifth problem, 12 volts. The switch is opened at t equals 0 after a long time, and you have a circuit in which you have two inductors. This is 2 Henries, 4 ohms. This is 4 Henries, 4 ohms. This is 1 ohm, I1 and I2. The switch is kept closed for a long time, so inductors have some currents established in them, and once the switch is opened, find I1 0 plus and I2 0 plus. This is an illustration of the situations where inductor currents can be discontinuous. So, using the principles that we have talked about, find out I1 0 plus and I2 0 plus. Assume that initial conditions have been reached prior to the closure of this. Well, when the switch is closed, steady state conditions have been reached, and therefore the inductors carry some current. Once it is opened out, find out the new currents. 6. The system function HFS is given by 2s plus 1 divided by s squared plus s plus 1 for a single input, single output, linear time invariant system. This is a linear time invariant system, single input single output system is this. Find the complex frequencies in the natural response of the system. Find the complex frequencies in the natural response of the system. Of the system. B, find the forced response to an input e to the power of minus 2t. If the input is e to the power of minus 2t, what is the forced response of the system? That is 6. Seventh problem. We have two functions of time, ft 0 to 2 seconds, which has a value of 1, and gft, which is a triangular pulse 0 to 1, this is 1, that is gft. These are the two functions ft and gt that are given to you. Sketch A, ft convolved with gft, the convolution of ft and gt. B, f of t convolved with itself. So, it would be advisable for you to work this out graphically. You can verify them by through analytical working, but a graphical procedure is more illustrative. The last problem, the impulse response of an initially relaxed, that means there is no initial stored energy, linear constant parameter network is 4 e to the power of minus 2t ut. That means this is h of t. Find the response of the network, of the same network find the response of the same network to A, an input ut, that means find the step response. B, an input e to the power of minus t ut. That is, taking this as h of t, use the convolutional principle, find the response to input of u of t, that is step response, and find the response to a general input e minus t ut, assuming once again that the network is initially relaxed.